He's fine. Hey, Caleb. We are doing review, chapter 3 review. I am recording this 5th period. They didn't get quite as far as you guys the other day. You guys got through 19. So if you want to fast forward this video, you sure can, to like where we start, number 20. All right, there you go. Okay. PQQRPR is the pattern that the law of syllogism does. If a number is a whole number, that sounds like P. Then the number is an integer, that sounds like Q. If a number is an integer, that is Q again, right? Integer means Q, or whatever that is. R is the rational number. So we skip over the Q part, we go straight from the P to R. So if a number is a whole number, if whole number, then rational number. And I'm totally abbreviating and doing all the things. Okay.
Wait, can we do this?
I don't care.
Yes.
Yep. Yep. Okay. All right. Always, sometimes, never. There are 3 questions. Always, sometimes, never. All right. Here we go. 16. A line contains exactly 1 point. Always, sometimes, never. Never. Why? You have to have, in order to make a line, you have to have 2 points in order to make a line. So never. Can never have exactly 1 point. It has to have more than 1 point. 17. Any 2 lines L and M intersect.
No, sometimes.
Sometimes. They could be parallel. They could be intersecting or perpendicular, right? Whatever. So sometimes. All right. Now this one is a little bit longer. If points G and H are contained in plane M. So G and H live somewhere here and here. G and H, and this is plane M, bleh, right? G and H are perpendicular to plane M. So they're saying G and H are on a line that goes outside of plane M at a perpendicular.
True.
Always. Wait. You didn't press sometimes. No, I just said bonds. I don't. Okay, good. Wait.
If G and H are contained in plane M.
Always. Never. Isn't that perpendicular?
No, if G and H live on plane M, that means they're flat on plane M. They are on here. There's no way they can now be on a line that's perpendicular to this plane. Does that make sense? So never. Never. Yeah? Makes sense? Does that make sense? If they're on that flat surface, there's no way they can be at a perpendicular line. Okay? All right, here we go. Proof. Woo! I think we've done this exact proof before, but it probably wasn't named the same thing. All right, now, you will have a proof on your test. And the boys' first period were like, no, what are we going to do? Well, okay, here's some things, right? So if I give you this proof, you should at least be able to get some of the points. For example, like, I know what goes here. Given. I know what goes there. That's given. Okay, that should be given to you. Those are free points. Okay? And also, one more thing. I know what should go here. Yes, you can. What should go there? What we're trying to prove right here. This should go there always, right? So PQ is congruent to RS. That should go there, okay? So I have 2 at least free points, right? Okay, but let's actually do it from here. And we have this line segment right here. And we are given, here's what we're given, right? We're given that PR and QS, those little pink guys, are the same, okay? So let's say like this is 10 and this is 10, right? Okay? Let's say this QR here in the middle is 7, all right? What do I know about PQ and RS? They're the congruent. They would both be 3. If my numbers are right, whatever, right? But we know that PQ and RS should be the same. That should make sense, right? We have to just go through and show why, right? Okay? So we don't necessarily know that it's 10 and 7 and 3, whatever, but I'm just showing you that if those are the same, then this bit should be the same as that one, right? Okay? All right, so let's do some things here. We have, to begin with, we start with the given. PR and QS, those bigger pieces, those pink pieces, are the same as each other. How do I go from PR is congruent to RS to PR is equal to QS? Yeah, definition of congruent. They did it down below as well. Definition of congruent, and I'm going to use the symbol instead of writing out the word congruent because I'm lazy. You can be lazy too. Okay? All right, now they do this thingy thing to us. They say PQ plus QR equals PR. Okay, so if I go up to this thing right here, PQ is this guy plus QR is this guy equals PR, which is this guy. What did I just do? Yeah, I'm adding segments together. Segment addition postulate. Okay, but wait a second. They do segment addition postulate again. Right? Because here we're talking about this guy, right? But then they're talking about, probably, we're going to talk about this one next, right? So QS is equal to which two pieces?
QS is equal to QR plus RS.
QR plus RS is equal to QS, right? Okay. All right, that's segment addition postulate again. Now in this next section, they have this guy is equal to this guy, right? Like this guy is equal to this guy. They have them equal to each other. Why?
Definition of
Nope.
segment congruent.
Nope. PR is right here. Do you see PR right there? And QS is right here. You see QS right there? So we took this guy and plopped him in, and that guy and plopped him in and set them equal to each other because it is substitution. Substitution. Okay, we just plop those in. Do you see why that's substituted? Yeah, yeah? Okay, now they say we're going to subtract. What are we subtracting out of here? Yeah, if I subtract a QR from both sides, minus QR, what are we left with? PQ equals RS. And then to go from equal to congruent, do we do definition congruent segments? Yeah, you betcha. Beautiful, beautiful. Love it. Okay, good? All right, next. Find the measure of each numbered angle and name the theorem. Okay, so number 20, we have angle 7 and angle 8. First and foremost, let's do the theorem first. 7 and 8 are what kind of angles? They're supplementary, but what else are they? Nope, they're not vertical. They are a linear pair. Linear pair. Okay, so that means 7 and 8 are going to add up to be 180, you betcha. Okay, so 5x plus 5 and x minus 5, those two add up to be 180. Okay, let's combine like terms. So here's my equal sign, 180. I've got 5x and x. That's 6x. Oh, man. Plus 5 minus 5, those are together, so they cancel out, right? So I just have 6x equals 180 if I divide by 6. X is how much? What's 18 divided by 6? 3. So 180 divided by 6 is 30. Okay, but they say find the measure of each angle. So I'm going to plug 30 back in here. 5 times 30 plus 5. 5 times 30 is 150. 150 plus 155. Okay? And then if I plug 30 in here, 30 minus 5 is 25. Now do both of those angles add up to be 180 to check my answer? Yep, they do. Okay? That was 20. Okay, find the measure of each numbered angle and then tell me what the theorem is. We used a linear pair there. Okay, 21. They have 8, 7, 6, 5, those angles, and they give us all of them, and what do we know? They all equal to 180. Okay, but here's the deal. Which theorem do you use in order to know that they all add up to be 180? No? It looks to me like we're adding 8 and 7 and 6 and 5, and we're adding all of the angles together.
Measurement addition.
You're close. You're kind of.
Angle addition.
Angle addition. It's not segment addition like we did up here, right? It's angle addition. Angle addition postulate. We are adding all of the angles together. Yeah? Beautiful? Good? Love it. Okay, now I'm going to cheat. I don't want to write them all out. Can we like combine like terms and like put them all together at once, right? E equals 180. Okay, so let's add all the x's together. So I've got 5x, 4x, 10x, 12x. How much is that? 31. I think it's 31x. 31x. Okay, then I need to add the 6 and the minus 12 together. Minus 6. Okay. All right, so I just cheated like I didn't want to write them all out. Okay, now we do the math. Add the 6. 31x equals 186, and if you divide by 31, You get? Did you check in with her? Oh. X equals 6. Okay, now we plug back in. If x equals 6, 6 goes in here. I'm going to do this over here. I'm going to say angle 5. Angle 5 equals angle 6 equals angle 7 equals angle 8 equals. Angle 5. 5 times 6 is 30. If I plug a 6 in here, 4 times 6 plus 6. You see where I'm at? 4 times 6 plus 6 is also 30. 7. If I plug a 6 in here, 10 times 6 is 60. If I plug a 6 in here, 12 times 6 is 72 minus 12 is 60. Do all 4 of those add up to 180? To check my answer. Yep, they should. Okay? All right, 22. We've got angle 11 and angle 13 that are given to us. Right? Angle 11 and angle 13. What are 11 and 13? Not yet. 11 and 13. 11 and 13 are a linear pair. Okay, but here's where Anna's going to come in. We also have to find 12. So what are 11 and 12? Those are vertical angles. So we need to use both of those things in order to show what all of the angles are. So angle 11, angle 12, angle 13, what each one of those is. Good, good? Okay, since they give me 11 and 13, we're going to set them equal to each other, add them up to be 180. What do you think? 11 and 13. Equal to each other or add up to 180?
Equal to each other.
11 and 13.
Oh, 180.
Add up to 180. So 11x plus 10x plus 12 equals 180. Okay, this makes 21x. I'm going to kick the 12 to the other side. That is 168, I believe. And if I divide by 21, you get something like, that divides kind of nice, I think. 8. Right? Look at the ones place. Like 8 divided by 1 is 8. 16 divided by 2 is 8, right? So 8. X is 8. If we plug in 8 right here, in for 11, 11 is going to be 88, which means that 12 is also 88 because they're vertical angles, okay? And I can plug 8 in here, and 8 times 10 is 80 plus 12 is 92, and do 88, 92 added to be 180? They should. Yep, yep. How about that? Good? All right. Here we go. All right. Angle 9 is 80 degrees, and angle 5 is 68 degrees. Okay. They want us to find, I'm going to write these over here. Angle 12, angle 1, angle 4, angle 3, angle 7, angle 16. So I can stay zoomed in. Can I do that? Whatever. This is 23, 24, 25, 26, 27, 28. Okay, I'm just moving them over so that I can like keep zoomed in. Okay? Yeah? Good? Those are my things. All right, they want to know what angle 12 is. Whoop. Angle 12 is this guy right here. He is 100. Why? What is he in relationship to 80? They are a linear pair. Does that make sense? Angle 12 in relationship to this 80 is a linear pair. Yeah, yeah. Perfect. Okay. Next, we have angle 1, which is this guy right here. He is 80 also. How's come? What is angle 1 and this 80 right here? The two pink guys. They're corresponding. Yep, I like it. Okay, erase. Angle 4 is this guy right here. Ooh. What is he in relationship to 80? No?
I just went from 12 to 4, which is corresponding.
You went from 12 to 4, which is corresponding?
Yeah.
Right? Okay, but what is 12?
100.
12 is 100, right? So 4 is 100, right? Okay, so angle 4 is 100. But in relationship to the 80, he's nothing, right? So we have to take 2 steps to go from this 80 to the 100. We could go from 80 to 12, which is a linear pair.
Do you have to do it that way though?
And then we have to go corresponding. Okay, if you're going from the original 80, you would have to take 2 steps. Kind of a pain in the butt. I don't know that I make you do that on the test, but there is that. Okay, good? Make sense? Ish, kind of? Oh gosh, I erased way too many things. Erase. Okay, the next one is angle 3. So we're on the bottom now? No, we're not. Angle 3 is this one right here. What is he in relationship to 80? Their alternate interior. And angle 3 is how much? 80. They'll be the same. Yeah? Okay, 7 and 16 is the next one. 7 is this one right here, and we know that this is 68. What is 7 in relationship to that 68? 7 and 68 is vertical angles. And that means 7 is 68. Okay, 16, oh my. 16 is this one right here.
180.
16 does not have a relationship with 68. But if we go from 68 to 7, that was vertical angles, right? Okay, and then what's 7 to 16?
112.
What?
112.
Yeah, it's 112, but what's 7 to 16? Consecutive interior. Yeah? So there's that. Good? Beautiful. Okay? Very good.
Do you want
Hold
are you
up.
gonna make us graph on the test?
For like this one, for like 29 and 30, no. There's going to be some other ones that you might have to graph. I would guess like maybe 1 or 2 on the test you'll have to graph. But they'll be like the last problems. And the one with graphs, I guess. I don't know. Okay? All right, let's do 29 together, and then I'll have you do 30 on your own. We're checking for parallel, perpendicular, and either. So I have MN makes a line and RS makes a line, and I'm looking at their what? Slope, right? If they're parallel, they'll have the same slope. If they're perpendicular, they will have the negative reciprocal slope. If they're neither, they won't have either of those. Okay? So let's do MN together, and I'm going to, the symbol that we use for slope is M. So I'm going to do M of MN, and I'm going to do M of RS. Zoop, zoop. And I'm going to do my Y2 minus Y1, X2 minus X1, all that good stuff, right? Y2 minus Y1 is 4 minus 3 over 2 minus 0. 4 minus 3 is 1, 2 minus 0 is 2, so that guy's slope is 1/2. Okay. RS, same thing. All right, what's Y2? 4 minus? Nope. 1, 4 minus 1. Over 8 minus 2. 4 minus 1 is 3, 8 minus 2 is 6, which is 1/2, so?
They're parallel.
Parallel. Those two lines are parallel. Beautiful. Okay? All right, you do 30. I'll give you like a 30-second head start, and then I'll go. Did you? Perfect. Too smart. Too smart.
Except that is negative.
Except.
You gotta take 0.
Okay, good. Perpendicular? Yeah, yeah. All right, next, let's graph. So they want this, they want to graph a line. I want a line to have a slope of 3 that passes through 6, 2. 6, 2. 2, 4, 6, 2. Start there, and I want to have a slope of 3, so up 3 over 1, up 3 over 1, down 3 left 1, down 3 left 1, make your line. Good.
Like, tough.
Ooh. Goodness. Then they get a little bit harder. Not too bad, but a little bit. Okay, 32. I want to graph a line that passes through 8, 5, but I want it to be perpendicular, okay, with these 2 points. So where are you going to start? Those 2 points. 0, 5 is here. 3, 1 is here. And here is that line. Okay. And if I want him to be perpendicular, let's find the slope of that line, right? I have him graphed. So from this point to this point, I'm going down 1, 2, 3, 4. No, that is not right. 0, 5, and 3, 1. Did I do that right?
It's negative.
Down 4 and over 3.
It's negative 1.
No, it shouldn't be.
It's 3, negative 1.
Oh, 3, negative 1. That's right. That's why I'm getting a different answer than I did this morning. I'm like, that's not the slope that we got. 3, negative 1. Thank you. I just seen if you were paying attention. That's a lie. So this slope now, we're going down 1, 2, 3, 4, 5, 6, and over 3, yeah? So down 6 over 3 means this guy has a slope of negative 2. Yeah, yeah? Okay, but I want my point to go through 8, 5, 2, 4, 6, 8, 5. Let's see if I can graph that guy. 8, comma 5, and I want him to have a slope of what? Yeah, he needs to have a slope of 1/2 if he's going to be perpendicular to the 2, right? These two have to be negative reciprocals. So from this point, I'm going to go up 1 over 2 or down 1 left 2, down 1 left 2, down 1 left 2, and he is not going to intersect at a nice place, correct?
Did you do that right?
Yeah.
You sure?
Yeah, I think so.
Can I show you the way I did mine?
What'd you do?
Well, I put 8 cubes come first. I did that. Then I did the y1 over x1, we know that. And I got 1/2. So from h, I just went down over, down over, down over. And I figured out that the other one was going to be negative 2, so then I just read the other slope for that.
Did you get the same answer as us?
Here, it should-
I gotta see what you do.
But it said it passes
What you
through-
doing? What you doing?
I thought it said passes through 8-5, so I just made it so that they both pass through 8-5.
Oh, but the only one that passes through 8, 5 is the one that I'm writing. The other line is AG. AG is the other line. He goes like this. Because you're not touching 0, 5 at all. That's the problem.
I
Yeah.
just did that.
The other line is 0, 5 and 3, negative 1.
Okay, thank
Yep,
you.
yep. Okay. All right, I'll leave that one up there for a second. Okay, 33. I want him to pass through 6, 1, but I want him to be parallel to these two guys, right? So I'm going to graph those two guys first. 2, 1, and 2, 4, 6, 7, 4. 2, 1, 7, 4. There he is. There he is, and there he is. Okay, that's my original guy. And the slope of that guy is up 1, 2, 3, and over 1, 2, 3, 4, 5. Up 3 and over 5. That's what his slope is. I want him to go through 6, 1, 2, 4, 6, 1 right there. But I want him to be... Nope. Parallel, right? So I want him to also be 3 over 5, right? Up 3 and over 5, or down 3 to the left 5. I think I did that right, maybe. Oh, no, I did not. I don't know. My line just was really not very good. Something like that. Up 3 and over 5, he should be the same slope as the other one. My pink line is not very straight, I don't think. Okay, so make sure you're paying attention to whether they say parallel or perpendicular. Those will kind of tricky sometimes. Okay? All right? Good?
Wait, what do we do for? Is it like up 1 over 1?
This one is the same slope, up 3 over 5. Same slope.
Both of them?
Yep, both of them are up 3 over 5. Because they have to be parallel. Parallel.
Would you stop moving the table?
Okay,
I don't appreciate it.
good. Beautiful. 34. Identify the postulate or theorem and solve for x. So we've got this angle here and this angle here. What do we know about those two? They are alternate interior. Alternate interior. That means that they are the same. 9x plus 1 equals 8x plus 8. And I'm going to subtract the 8x. And can I subtract the 1 at the same time? So x equals?
So
7, I believe.
7.
I think. X equals 7. Okay?
Alternate exterior.
They are alternate exterior. I heard a ton of people say it. Yep. Alternate exterior. And that means they are the same. 2x equals 3x minus 20. And I'm going to subtract my 3x and we're going to have negatives, which is fine. Negative x equals negative 20. But if I divide by a negative, then x equals 20.
10.
Alternate exterior. Alternate exterior. Okay? 36. I'm flying kind of fast. This angle right here and this angle right here are corresponding. We were trying this morning. I was like, who in town is corresponding? Do you guys know who, like, Athena West, is it Westerlin is? She, when she was in school, she used to be corresponding with, like, Pam Schwab, Pam Otterburn. Yeah, I don't know. And now I'm trying to think, like, who would be corresponding anymore. So does anybody have the same corner of the intersection? Like, if we have 2 streets that go this way and somebody's here
Yeah.
and somebody else is here? Who?
It used to be Ryler Afton over there on that one, and then you go block up, and Jack's parents rent out that one.
So Ryler and who else?
And Jack's parents rent out that one house to randomly.
Jack Canterbury?
Yeah, Jack Canterbury's parents rent out.
Okay. I don't know where this is at. Do you guys know where this is at? Yeah. What? Olson and you. Like Mrs. Olson?
Mrs. Olsen, the Mrs. Olsen, the one across the hall.
Uh-huh. And you are you the same spot? But down, you're on the corner, right? Yeah.
Ew.
So Mrs. Olson would be like different intersection, right? So and this road is not there, right? Like Mrs. Olson's house is here, but there's no road that goes through. I don't think there's a road that goes through, right? Mrs. Olson would be there, and then like your house would be, no, but your house is here.
Oh wait, no, that's
It'd be
your
my
grandma's house.
it'd be my grandma.
That's your grandma's house.
Yeah.
Never mind.
My grandma's house is on
My
like the
grandma.
alleyway. No, not really an alleyway, the dirt road.
I
Where
forget your
Johnny Hedge
grandma's
used to
house.
live. and then
Okay.
my grandma's.
So your grandma would be like here where the alleyway is.
Yeah.
Yeah. Okay, so you would be corresponding to his grandma. Okay, perfect. Yeah.
His house is like a lot.
Okay, we were trying to figure that out this morning. We couldn't remember if there was anybody. So, yeah, there is. Okay, so these are corresponding. CORRESP. And that means that they are the same. They equal. 5x plus 20 equals 70. And if I subtract the 20 over, 5x equals 50. And x is 10.
Oh,
Boom.
I was just ahead of you guys.
Yeah, beautiful. Beautiful. Okay.
Aren't you just
Good.
too
Very good. All right, last two. And then we might do a note card quick.
No.
Because we did that this morning.
Can we do that tomorrow too?
What?
What are we gonna do tomorrow?
Well, we're going to whiteboard tomorrow.
Okay.
Yeah.
I thought we were going straight into this.
No. 37 is y equals 8 and y equals negative 3. We're trying to find the distance. Do you know how to find y, or how to graph y equals 8?
Yeah.
Go to 8 on the y, which is up here, and we go this way. Y equals negative 3, 1, 2, 3, and right here. And how far apart are they?
11.
That's super nice because we can just count, right?
Yeah.
But in the next one, we cannot.
That's so sad.
We cannot. We cannot. Okay, so next one. X plus 3. I got to graph this. Woo! Woo! I'll give you a nice good graph paper on the test tomorrow. Not tomorrow. For Thursday. X plus 3 if I graph him.
3.
You go start at 1, 2, 3, and we put a dot, and then the slope is 1. So you go up 1 over 1. Up 1 over 1, or down 1, left 1. Down 1, left 1. Oh gosh, I can't.
That was perfect.
Down 1, left 1, down 1, left 1. There you go. There he is. Something like this. That's what he looks like. Okay? Now, this guy, I start at -1, so there he is. But he also has up 1 over 1. Okay? Up 1 over 1. Up 1 over 1. Or down 1 to the left 1, down 1 to the left 1, etc., right? Something like this. And those two lines are, wow, they're supposed to be parallel. Sorry. Okay? They want us to find how far apart they are. And it would be really nice if I could just count here. And that would be 5 or 4. I mean, the distance between 3 and -1. But that's not true. Because that's not how the steps on the ladder go. The steps on the ladder go this way. Right? Whoop. Come on. Steps on the ladder go this way. Something like that. So I've got to find one of those and figure out the distance of that. Okay? So I'm going to, like here, maybe. Like there. Or there. Or there. Or there. Right? Do one of those. Which one do you want to pick of those 4?
0, 3, and 2, 1.
0, 3, and 2, 1. You want to pick this one right here?
Yeah.
Okay. So 0, 3 is there. 2, 1 is where he touches on this side. So we need to do the
4, 4,
distance. You're right. 0 to 2 is 2. 3 to 1 is 2. 2 squared is 4. 2 squared is 4. The square root of 8, which is 2.8, approximately.
Such a dog.
Approximately 2.8. That's how big this step is. Boom. Yeah? Okay, I'm going to give you a note card, and we're going to write down these guys. But I got to erase first.
If a dragon lays then a girl's a dragon.
Oh my gosh, what are we doing here? Come on.
Not in your bag.
Come on. Come on. Why? I don't like this new update here.
I'm a dragon.
Got a problem with me? I was gone yesterday. Old slice.
Okay.
Okay, let's see if we got them all. Okay, I'm going to give you a note card. Caleb, you need to come get a note card from me. On the front of the note card, this is what we're going to do. I don't care if you do it up and down or sideways.
Can I?
Period.
Oh, yay.
Yeah.
So you can, but like, there's that, okay? The conditional is the original. And we're doing this one. And that should be not raggin', it should be a dragon. Do you guys follow Mrs. Like, Ochter's classroom stuff going on?
If I poop,
She has
I
a
faint.
she has a bearded dragon in there. Have you ever seen it? Have you gone down there? She has a bearded dragon. Okay, so in her classroom, it's Crazy Carl is the name of the bearded dragon, but it's not Carl anymore because it started laying eggs, and they're like, oh, Carl is a woman, so it's a woman dragon. So they named it Karen. So it is Crazy Karen now, and not Crazy Carl. But they just found out a couple days ago that it is not a boy dragon; it's a girl bearded dragon. What?
Same thing that happened to Robbie and Jesse. He found out his lizard was a girl. They had eggs.
Oh, nice. And in what? What is this?
Jesse?
Jesse.
The Disney Channel show. Hey, Jesse.
I don't know what you're talking about.
Feels like a party every day.
I have no idea what you're talking about.
Hey, Jesse. Jesse? You don't
Okay.
know who Jesse is?
I don't know who that is. Okay. I'm sorry. I don't
Party
know.
every day.
Okay, so our conditional, which is our original, is our if then. And he takes the form of PQ, right? P then Q. Okay? Which one is the P part?
If the dragon.
If the dragon lays eggs, that's the P part. The dragon is a girl dragon, that's a Q part. Okay? All right, if the dragon lays eggs, then it's a girl. True or false? True. If it lays eggs, it has to be a girl. Sorry, that's just how it goes. I know we're in 2025. That could be debatable, but, you know, I'm just going to go with that. All right?
What if a male dragon ate a whole egg?
Where am I? Oh my, oh my, oh my. I don't think that's how that works. All right, now the converse. Okay, so we did the symbols to represent the conditional. How does the converse work?
If a girl, then a dragon.
Yep. So what symbols do we do? It's not PQ, it is QP. It's flipped around, so it's Q then P. So if what? If it's a girl, then it lays eggs. If it is a girl dragon, then it lays eggs. Is that true or false? If it's a girl dragon, then it lays eggs. I don't know that I necessarily think that that's true.
Look,
It's like saying if a person is a woman, then it has children.
not true.
Not true, right? It's not necessarily going to lay eggs, right? Mrs. Oxner just found out, Crazy Carl or Karen was laying eggs and it laid like a few, whatever, but she could still like feel its belly and like knew that there was a ton more eggs. And she's like, why is she not laying all the rest of the eggs? Well, she did a bunch of research and found out that like they lay eggs in like a warm temperature. So she put like a heater in the tank and set it to like 80 degrees, whatever. And like overnight, she dumped all of these eggs and was like tripled her egg count or whatever because like they had to have a warmer temperature. What? I don't know. They're not fertilized eggs, so it's like a chicken egg that's not like fertilized or anything. Well, you have to have them fertilized first, and they would have to be. They would have to already have been fertilized.
We're gonna need a male.
So they're basically useless now. Whatever.
We're having a pin with it.
Anyway, so if it's a girl, then it lays eggs. Not necessarily true. There's a lot of female people out there that don't have children or don't have any eggs or whatever, you know. So, what?
Well, you're the teenagers.
What? You females do not have children. Yes, right. Okay, now inverse. The inverse is the opposite. I always say the first one and the third one go together because they're in the same order, except they are not. That's the squiggle part. Squiggle P and squiggle Q. Not. So they go in the same order as the first one. If what?
If not a girl.
If I don't.
If no eggs, then
No girl.
not a girl. Okay, if my dragon doesn't lay eggs, does that mean it's not a girl? If you guys don't have children, does that mean you're not girls? No. Right? False. Okay? If no eggs, then not girl. It's just hasn't decided it wants to lay eggs yet or something. I don't know. Okay, now the second one and the fourth one go together. They're in the same order except they are not. Not Q and not P. Though that is the contrapositive. Okay, so I go in the same order as this one right here. If not girl, then no eggs. So my dragon is not a girl dragon. Does that mean I'm not going to have any eggs? Yes, that is true. There's no way they're going to come out of a boy dragon. Okay. Good? Make sense?
Yep.
That's your example of conditional, converse, inverse, contrapositive, all the things. Okay? On the back side of this, I want you to put the law of detachment, and I'll write the statement out. Law of detachment and the law of syllogism. The law of detachment, law of syllogism. You can put this on the back side of your note card. This is it. We have 3 minutes? Oh, should we wait and do this part tomorrow?
Yes.
Yeah. Okay. All right. Caleb, you're going to be behind because we already wrote this down, but you can get it from somebody else tomorrow. We will whiteboard tomorrow after we finish writing this note card down and test on Thursday and then no school Friday. Woo!
Freak yeah.
Yeah. Okay. Goodbye.
Grades on.